Hey there, Nick Takas here. In this video, we're going to go over how processing lines of output in a loop within your shell can be really slow depending on what you're doing. For example, let's say that you have some grep output and you want to loop over each line and do some custom parsing or calculating or running some processes there in the loop. Yeah, it's running those processes in a loop that's going to be really slow. Now, you may have used the command line before, right? And used tools like grep, cut, sed, awk, wc, etc. And things have been very fast. You can feed in these tools a 100,000 line file. It's going to produce a result in maybe 100 milliseconds or less. And that's definitely the case here. But yeah, it's really when you introduce some custom shell scripting loops and you're running some process in those. So I've set up a little demo script, a couple of different CSV files. One of them has 10,000 lines. The other one has 100,000 lines. We're going to play around, see how things go and how it actually led me to rewrite Plutos, the income and command line expense tracking tool that I made a video about previously, from Bash into Python. So yeah, let's take a look here. And maybe before we even jump into the shell script examples, let's maybe just use the command line for a second here and just like maybe grep out business expenses here in the CSV file here. This is going to be, let's go with the 100,000 line file here. And that's pretty fast, right? I don't know how fast it was exactly. Let's time it. It is going to be, yeah, about 260 milliseconds to go through 100,000 lines and then also produce how many lines of output? About 32,000. I know grep can count this as well. Just demonstrating that, you can take the output of another tool, pipe it into something else, and then do whatever processing really fast here, right? This is like not instant, but very fast to the point where you're not going to be complaining, right? Okay, cool. So let's go over this demo script here and see how things go here. I did prepare a couple of things ahead of time. We're going to kind of play with the script incrementally here. I did, by the way, change this to run against the 10,000 line file instead of 100,000 line because you're going to see things take already pretty long, even with 10K lines. So let's just run the script though, how it is right now. And that's basically going to do nothing. We can just time this one. Sure. Okay. And we can see it finishes in about, I don't know, let's call it 30 milliseconds. And this, what it's doing is just taking all the grep results here, putting it into a variable, and then we're going to be looping over that variable line by line. Just using a read line here, basically. And then in this case, a colon here is essentially like pass in Python. It's essentially a no-op. It's not doing anything. That's why, it is pretty quick here. But yeah, let's start actually doing something, right? Maybe, I don't know, running an echo instead, just to get each line of output here produced here. And that runs pretty quick. Still, we are dealing with 10,000 lines here. And, that runs in what, I don't know, not even 100 milliseconds. That's really fast. And it can even be quicker too, right? Maybe we can echo things and just redirect the output to dev null so it doesn't get output to the screen. And then, yeah, cool. This is like already like 75 milliseconds. That's a lot quicker. Cool. Okay. Let's run a WC though. Like let's get the count characters in every line. All right. All right, this is starting to take pretty long, like, 3.5 seconds to count the characters here. And, this is sort of a silly example. Why would you ever do this type of loop just to count the characters? You can use something like awk instead. That's why I have this little example here. Let's rerun the awk command version of this one. Yeah, it's still going to do the same thing in about 30 milliseconds. Pretty freaking fast. And, let's even go to a 100,000 line file with the awk one. Yep, 200 milliseconds, give or take. Also very fast. And, I will say that 100,000 is about 10 times 10,000, right? Where it is exactly, right? So, let's not run the 100,000 line version against this because this will take over 30 seconds on my machine, at least about 35 seconds. And you might be thinking though, like, is it just like word count? Like, is WC like just slow? Maybe you can just run cut instead or, some other tool. And here we're just cutting out the first column of the CSV file. And that's also taking about 3.5 seconds. And what's really painful about this one is if you're in this loop here doing some stuff, then yeah, let's say you're doing two things. This is going to take double the amount of time. So now it's going to take, 6 seconds and change to finish here. You can see it's going and going and going. There we go, like 6.5 seconds. Now, when I was writing Plutos originally as a shell script, I was doing this type of thing where, grepping for matches, then going over those matches, doing a whole bunch of different calculations, like, updating variables and doing this and doing that. Like I couldn't just pipe stuff cleanly from one program to another. And I found it running taking forever, like tens and tens and tens of seconds on like 1,000 items. And what if you have 10,000 items or more? It just got to be a little bit too slow here. And by the way, there is an example that we can pop into the terminal to actually try it on your end too without needing these CSV files. So if we just run this here, let's run that. That is going to run. It takes about 1 second, 900 something milliseconds, let's say. Let me bring this up here so maybe we can all read this one on screen together. But yeah, in this case, we are just calling bash here. And what are we doing? Well, we're just doing a loop 1,000 times here. And we are just going to pass in I, basically. It's going to be 1, 2, 3, 99, 9, or 1,000, whatever. And, just getting the character count, basically, of the actual number inside of this loop here. And that's already just taking 1 second here to do 1,000 items. And if you do, I don't know, 10,000 items, then It's also going to take quite some time here to finish. How fast does it take in your machine? Let us know in the comments, right? This is a 10-year-old computer I'm working on, so I'm sure yours is going to be a lot faster here. But here we're just looping over 10,000 things in loop here, and it's taking about 10 seconds. And yeah, pretty slow there, but it is something that is reproducible here. And if we do a very small modification of this one, for example, same thing, but instead of doing the word count here, we just do a no op. No op takes basically no time. Let's do it again for 100,000. Also 150 milliseconds to crank through 100,000 things in a loop in a shell script. That's pretty fast doing nothing. Now, what's really interesting though is, commands like echo tend to be pretty quick, right? For example, let's going back to this example from the demo script. Yep. All right, let's go and rerun this one. That runs pretty fast. It's not like nothing, but it's a lot faster than any other thing. And that is because echo and printf, at least with bash, these are built-ins. I don't think these are making external process calls in the same way that these two, I never hooked that up to like some debugger or tracing tool to see exactly what's happening under the hood here. But if you run something like which echo, it will just say that it is a built-in here. And now technically I am running, Z shell here, but let's just go with bash. That's why actually that other command has bash c there, because technically that loop wouldn't have worked in Z shell here. But let's just say which echo here, and then yeah, actually it does look like it's a binary here. So I don't know. Actually, I'm not 100% sure then why this is a lot quicker, versus WC, because we are using bash here instead. Maybe this is actually something different. I don't know what this is. We are now in complete uncharted territory here. Yeah, I don't know. It is some binary file. So, okay, cool. So let us know in the comments below if you understand why echo and printf are a lot quicker than some other process that you might be calling here. But we're not done yet. I kind of just wanted to maybe also go to a blog post version of this video, which, whatever. Let's skim over all this stuff, the other stuff, because we just demonstrated all of that. But yeah, I just wanted to, I will mention here too. Yeah, I don't want to miss this one here. We kind of mentioned before that, right? It took about 6.5 seconds to run through both of these examples here. But if I did that on the 100K line file, then it actually takes 1 minute and 12 seconds here with 37,000 matches, basically 10 times the other one, which is a lot of time here. And also, if you Google around for some of this stuff, they might be like, oh yeah, just use like read array here instead. And then you can just loop over the array like this one here. But in this case, it made no difference at all. It was still equally as slow, because I don't think it really has to do with like the looping construct in bash itself or the shell here. It's running a process in that loop, which we demonstrated before. But yeah, this is the part I just want to go over here a little bit, because yeah, bash is amazing, except when it isn't here, right? I've been writing shell scripts for, I don't know, almost a decade here, solved many different types of text processing problems, and you can get some really fast scripts going on, just piping stuff between tools here. But yeah, if you need to do some custom processing, then I don't know, you kind of have three options, right? It's one, you become like a literal god with awk and Perl. Maybe you also just accept the slowness because possibly it's okay. Or maybe you just take the slow part, like that loop, and you just move that logic into another scripting language or another tool or something like that. Or you can kind of just like rewrite the whole thing in Python, or, whatever your preference is there. And for me, I never really super got into awk and Perl, but I know they are very powerful tools here. And I remember spending once like 30 minutes using awk to convert human time formats, like, 1 hour like this, space like 30M, or maybe 90M, like 90 minutes there, into decimal hours, such as like 1.5 here. So here's a code here that I cobbled together from, I don't know, half a dozen different sources on the internet, Stack Overflow, blog posts, everything I could possibly find here. It's part of this invoicing script that I open sourced, I don't know, like 6-7 years ago. I think I made a video about that one. I'll leave a card if I did. Yeah, I'm pretty sure I did. But yeah, I mean, look at that, right? Like, by the time I was done with it, like, it was really good. It was robust. It works amazingly well. It supports all sorts of different edge cases, now depending on if you use spaces, like too many spaces, and I don't know. But it kind of felt like I also lost 5 years of my life in the process of putting that together. I also don't want to have to write 30 lines of comments for each one line of awk here. And, and that's not a shot at awk too. Like, it's a great tool here. But if we go to this invoice script here, just real quick, it's like, yeah, here is all the comments that I ever had to write to remind myself like what this did. Now, if you're already really good with awk and you know all the stuff, then maybe you don't need all the comments here. But yeah, I don't know. I just didn't feel like that was a sustainable road for me to do that type of thing. And, going back to the other bullet point here around accepting maybe slow speeds here, I'm a really big fan of this one book called The Pragmatic Programmer. It's basically a whole bunch of different tips. They're all timeless. It kind of works with any tech stack because it's more about general philosophies and ideas here. But it has this one tip around like broken windows. And, that Pluto's income tool tool or expense reporting tool that I've been writing here, I'm going to be writing that at least once a month. I'm going to also be inputting stuff on a pretty regular basis here. And I just don't want to be reminded of the inefficiencies of the tool every time I run it. Waiting 3 or 5 seconds for it to generate a report, that's going to pretty much kill me on the inside, especially when I put together a proof of concept in Python. And I was seeing the same thing being produced in about 30 milliseconds, just using basically like opening up the file, looping over the lines, doing whatever you need to do there. And I also knew I wanted to open source that tool. And I know how important I value performance, within reason there. So I've actually just completely thrown away using other tools just because they open too slow. And, as for like maybe just swapping out certain components of the script to work with Python instead of Bash or something, I don't know. I kind of didn't feel like it was worth it to try to break that up. And I just decided to rewrite all of it there. I learned a ton along the way, so I'm really happy that it did it there. But that also doesn't mean Bash is, horrible or useless, right? I use it all the time. I'm going to continue to use it and develop scripts all the time using it because it's a great environment for building and putting together things. And it's okay to use other tools as needed here. But honestly, realistically, once I got into Plutos a bit more, Python just made to be a better choice anyways, right? There was a lot of command line argument parsing, subcommands, like really robust CSV linting, data structure requirements, had to do decimal calculations and all that other stuff where, trying to do all that stuff in a shell script wasn't working out nicely anyways. I found myself, fighting things here or there. And I think that's a great time to rethink, to be like, maybe this isn't the right tool for the job and maybe use something different here. But anyways, this is now meta information because the video doesn't exist yet. But that's going to do it for this video. I'm kind of curious to hear your opinions and thoughts on this one. Is there a more efficient way to do this one? Is there something else that you would have done differently? Or maybe you've done the same thing. So let us know. With that said, if you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I'll see you in the next one.